Hello, I'm going to start with the definition of function. What is a function? A function is a relationship between two variables where each input corresponds to exactly one output. So these two things are important and notable here in this definition. Each input and exactly one output. Each input should corresponds to exactly one output. So what does it mean? I'm going to explain with the help of an example here. This is example of the function uh, that this is some set A and this is some set B. A has elements 1, 2, and 3, and B has elements A, B, and C. I am naming this relation F. 1 is mapped with A, 2 is mapped with C, and 3 is mapped with B. Here you can see that this set A has these three elements, and each element is has some output in set B. So this condition is being fulfilled here, that each element in set A has some output and exactly one output. One has one output, which is A, two has output C, three has output B. So this relation F is the function from set A to set B. Next, I'm going to explain another. Now there is another example uh, of function from A to B. One has output A, this is, and two has output B, and three has output C. Each input has some output and unique output. One has one output which is A, two has one output which is B, three has one output which is also B. So this is also function from A to B. Now there is another example of a relation between A and B. Uh, one has output which is B. I'm talking about this H. One has output B, two has output C, and three has not any output. Each input should have some output. So three has no output, so this H is not function. Okay, this is another example of a relation from A to B. I have named it J. You can see that one has output which is A, two has output B and C. Since this two has two outputs, so it means that this is not a function because each input should have exactly one output. 2 has two outputs. This is B and this is C. So it means that this is not a function from A to B. Okay, next, domain. What is the domain of the function? All possible input values. All possible input values of the function are called the domain of the function. So in this example, domain of this function f, domain of this function f is 1, 2, and 3. Now, domain of this function g, what is this? This is also 1, 2, and 3. This is the domain of the function g. And domain of this function h is 1, 2. I'm sorry, this is not a function, this is a relation. So domain of this relation is 1, 2. This is the domain of relation H. Now, domain of this relation J is again 1, 2, and 3. Is 1, 2, and 3. This is the domain of this relation J. Now, what is the range of the relation or function? This is the definition of range of the function. All possible output values or the range of the function. We also call dependent variable values of range. So uh, in these examples, this f has the range a, b, and c. So this is the range of the f, a, b, and c. And range of this g is a and b. Range of g is a and b. C is not included in the range of this function g because c is not output of any input value. So range of g is a, b. And what is the range of this h? Since we have discussed this uh, later that this h is not a function. This is not function. So we will call this relation. This is a relation between A and B. So BC is the range of this relation H. And this is also not a function, uh, not function. So this is a relation between A and B, and its name is J, and its range is A, B, and C. Hopefully you have understand this domain and range. This is the range of H. You can assume the function as a machine. This f of x is a machine which takes some output in the form of x and gives us output in the form of f of x. Uh, just like any other machine, like we have a bulb and we are providing electricity to the bulb, and electricity is the input of the bulb. As a result, bulb gives us output which is light. So electricity is the input and light is the output of bulb. Now there are few notations to represent a function. First one is this f. X is the input and it is going to give this output 2x cubed plus 1. Other one is f of x. F, then within bracket we have to place x and this will give us output 2x cubed plus 1. And next one is y is equal to 2x cubed plus 1. This is the same function, uh, but these are three different notations to represent a function. Usually, it, uh, commonly we will use this notation. In most of the literature, this notation is used. So we will focus over this notation in future. Uh, Next is this vertical test for the function. Suppose you have a graph of some function, and how can we determine from the graph that whether this graph corresponds to a function or a relation, or whether this graph uh, is drawn from a function or a relation? So this is a vertical line test. Vertical line, a graph represents a function only if and only if no vertical line intersects the graph more than once. For example, this is a function y is equal to x squared and this is its graph. Uh, how can we apply this vertical line test to check whether this is a function or not? We have to draw a vertical line. If this vertical line is intersecting the graph at single point, each vertical line, this is also a vertical line, it is also intersecting this graph at a single point. You can draw any vertical line at this graph at any point. This vertical line will intersect the graph at a single point. So it means that this is a function. If the vertical line intersects the graph at more than one points, then this is not a function. Now there is another example of a function. Now x is equal to y squared. If we draw its graph, this is its graph. So we have to check by using vertical line test whether this is a function or not. So we have to draw a vertical line at any of these points. So you can see that this vertical line is intersecting this graph at 2 points. So it means that this graph is not a function. This is not function. Now I'm going to discuss the domain and range of the function once again. Uh, we can also define the domain of the function as all input values for which the function is defined. All input values for which the function is defined is called uh, domain of the function. For example, we have this function f of x is equal to 1 over x, and now you have to think about the values of x for which this function is not defined. For example, this is function 1 over x. If we substitute here 0 in this function instead of x, in place of x, so 1 over 0 is always giving us undefined or infinity. If you use calculator to calculate this 1 divided by 0, you will get math error. This is meaningless statement that one object is being divided or distributed among 0 objects. So this is not defined, this is meaningless. So 1 over 0 is always infinity. Whenever any value is giving you output infinity, this is output. If any input value is giving you output as infinity, then you will exclude this input value from the domain of the function. So what is the domain of this function f of x? So domain of this function f of x is set of all real numbers except 0. You are excluding 0 from set of real number. You can also represent this as set of real number uh, minus 0. This is also a notation to exclude 0 from set of real number. So this is the one example for the domain. Now I am giving you a little more complex example. This one, f of x is equal to 2 divided by x minus 2 plus 1. So if you have to find the domain of this function, you have to think about the value of x at which this function is giving us infinity output. So you can see that if you substitute here 2 instead of this x in place of this x, if you are substituting here 2, then what will we get? F of 2 is equal to 2 divided by 2 minus 2 plus 1. So this will give us 2 divided by 0 plus 1. So 2 divided by 0 is infinity, and infinity plus 1 is always infinity. So this 2, this input value 2 is giving us infinity. So it means that uh, this 2 is not included in the domain of this function. So what is the domain of f? Domain of f is set of all real numbers but not 2. So this is the domain of the function f. Now there is another situation in which a function is not defined. I have explained these two examples. This is 2 over x minus 2 plus 1, and first example was f of x is equal to 1 over x. In these examples, you have to think that at which values the function is going to give us output as infinity. But there is another case also, which is important. Uh, Square root function, any function which has square root involved. So in this function, you have to think about a number or input at which this function is going to give us imaginary number. So if you substitute here -1 in this function in place of x, so this square root of -1 is always iota. If you try to calculate the square root of -1 by the help of calculator, this will also give you math error. So this is not a real number, this is imaginary number, iota. So -1 is not included in the domain of this function. We can substitute any negative number. For example, you are going to substitute here -5. So -5 on both sides. So this is, you can write this 5 times -1. If the two numbers are multiplied with each other, then you can separate their square roots. Square root of 5 and square root of this -1. So this is the square root of 5. Square root of -1 is actually iota. So this is also a complex number. This one, square root of 5 iota, is also a complex number or imaginary number. So the input at which the function is giving us output, imaginary number in the form of iota or in the form of infinity, then we will exclude this input value from the domain of the function. So now what is the domain of this function f of x? Domain of this function f is only non-negative real numbers from 0 to infinity. We have excluded each negative number from its domain because at each negative number we will get imaginary number or math error at the calculator. So domain of this function is from 0 to infinity. This is the domain of this function from 0 to infinity. Uh, so I would like to conclude for this domain uh, which input value is not included in the domain of the function. Number one, at which the function is going to give you output as infinity, or number two, imaginary number, which is in the form of iota. You will exclude those values of input from the domain of the function, which will give you output infinity or this imaginary number iota. Okay, now I would like to discuss the range of the function again. All the possible output values of the function, all the possible output values the function can produce. So these values are called the range of the function. For example, this is f of x is equal to x squared. So now what is the range of this function f of x? The range of the function f of x is a set of non-negative real numbers. Non-negative real numbers. Why this is the range of this function? Because this function f of x is equal to square of x. So for any output, for any value of input x, this function will always produce positive value or it will produce 0. When you will substitute here 0, this will give us square of 0, which is equal to 0. When you will substitute here 2, this will produce square of 2, which is equal to 4. If you set x is equal to -3 on both sides, this will give you square of -3. This is -3 times -3, which is equal to +9. So it is always producing positive value or zero. So that's why its range is set of non-negative real numbers. So why we have not written here set of positive real numbers? Because of this zero. Since zero is also included in its range, so we are saying that set of non-negative real numbers. We have excluded negative real numbers because of this square. Square, due to this square, it will always give us positive output or zero. If zero is not included in the range of a function, then we say that set of positive real numbers, because zero is also our output in this case. So we are saying that set of non-negative real numbers. Zero is the only number which is neither positive nor negative. Now there is another example of range. Now function is f of x is equal to sine x. Now what is the range of this function? So range of this function is always between -1 and +1. Whenever you try to calculate the value of sine x, it will always produce a real number between -1 to +1. It will never be greater than 1 and never be less than -1. So value of sine x will always remain between -1 and +1. So this is the range of f of x is equal to sine x. Okay. Now there is another example, uh, comparatively little complex than the first two or three examples. So this is f of x is equal to 2 over x minus 2 plus 1. Now, how can we find the range of this function? So it is better to uh, understand about the value of this factor first. Since we know that this value can never be zero, there is no any input uh, at which this function is equal to zero, this whole value 2 over x minus 2. I'm talking about this one. This value is never zero. So it is always, it may be uh, less than 0 or greater than 0. But any number which is going to be added in 1, so this will always produce a real number. So this value can never be equal to 1. This whole value, this whole value can never be equal to 1. Why this is not equal to 1? Because this is never 0. So if this is never 0, this 2 over x minus 2 is never 0, then f of x is equal to 2 over x minus 2 plus 1. This value is never equal to 1. So what is the range of this function? Range of function is equal to set of all real numbers minus 1. We can exclude 1 from the range of this function.